Today, we're diving into three very different but equally intriguing AI papers. One from Yale on how GPT-2-style Transformers may learn subject-verb agreement through collocational bootstrapping. One from the National University of Singapore on EmoTrack for robust depression tracking in counseling transcripts with Qwen3.5 and Qwen3-Embedding. And one from National Taiwan University and Johns Hopkins on ICICLE, a new way to expand retrieval with in-context documents using Qwen3 and DPO. From syntax to mental health to search, this episode is packed with fresh ideas. Let's explore the first paper, Collocational Bootstrapping, a hypothesis about the learning of subject-verb agreement in humans and neural networks. Claire Hobbs and R. Thomas McCoy at Yale University propose collocational bootstrapping as a mechanism for syntax learning in which learners infer subject-verb dependencies from word co-occurrence statistics rather than from explicit syntactic cues. They test this with two-layer GPT, two style decoder-only transformers trained from scratch on 12,000 synthetic English-like sentences per condition, varying subject-verb pairing predictability with a truncated zip distribution parameterized by alpha from 0 to 3, plus an alpha infinity no variability case. Crucially, the training data were fully ambiguous between agree subject and rival rules such as agree recent. Performance on 1,000 minimal pair test items per condition showed a sharp, non-monotonic effect. Models failed when subject-verb pairings were too variable or too predictable, but generalized best at alpha is approximately equal to 1.4, where they achieved near-perfect accuracy even on unseen subject-verb pairs with intervening agreement attractors. The authors then parsed 4,739,189 adult-to-child utterances from childs with spacey, extracting 2,802,071 subject-verb pairs from the top 100 verbs, and found that the empirical co-occurrence distribution is also Zipfian, with best fit alpha equals 1.43 overall and age stratified values from 1.46 down to 1.23. The key novelty is the alignment between the model's optimal variability regime and the statistical structure of child-directed English, suggesting that natural co-occurrence patterns may make abstract subject-verb agreement learnable through distributional cues alone. Let's explore the second paper, EmoTrack Robust Depression Tracking from Counseling Transcripts Across Session Regimes. EmoTrack, from researchers at the National University of Singapore, tackles PHQ-8 depression tracking in counseling transcripts across both single-session and multi-session regimes. The core idea is hybrid. Instead of relying on end-to-end fine-tuning or holistic LLM prompting, it uses Qwen3, 5, 3, 5B, A, 3B to extract 23 structured clinical features from an ADA-style schema, combines them with frozen turn-level semantic embeddings from Qwen3, Embedding, 8B, and feeds both through a lightweight transformer encoder-decoder with 8 PHQ symptom queries plus an optional previous session memory module. The authors also introduced long counsel, 8, a synthetic longitudinal benchmark with 3,599 5-visit trajectories and 17,122 labeled sessions, built from PsycEval cases, PsycGD severity trajectories, enhanced symptom co-occurrence patterns, and real CBT dialogue calibration. It provides session-level PHQ-8 supervision for control testing of partial disclosure and cross-session continuity. On Dakewas, EmoTrack reduces MAE from the strongest AIDA baselines 2.8234 to 2.4434, a 13.5% relative improvement, and on long counsel, 8, it reaches 2.6478 MAE, matching the strongest longitudinal baseline closely at 2.65. Ablations show that client-only turns, combined clinical features plus embeddings, symptom-wise supervision, and compact memory retrieval each contribute materially, while direct history concatenation offers little benefit. Let's explore the third paper, ICICLE Expanding Retrieval with In-Context Documents. ICICLE, from National Taiwan University and Johns Hopkins University, reframes incremental generative retrieval as an in-context indexing problem rather than a parameter update problem. Instead of retraining a retriever to learn new document DOSed links, it supplies newly added documents and their titles as inference time evidence, then teaches a Qwen3-1-7B base model to route between contextual copy and parametric memory using a special copy token, hard negative in-context templates, direct preference optimization, and a large title context LoRa adaptation stage. On MS Marco and NQ320K with 90/10 corpus splits and up to 100 inches context candidates, ICICLE reaches 0.607 hits at 1 and 0.8 hits at 10 on unseen MS Marco documents, and 0.649 hits at 1 and 0.772 hits at 10 on unseen NQ320K documents, outperforming incremental baselines such as DSI++, DOME, and no retrain DSI, while avoiding OM or ON+M corpus update costs. The paper's main technical finding is that scaling failures are driven less by retrieval ranking than by routing failure. The model often knows the answer, but fails to activate copy as the candidate set grows, and DPO substantially improves this source selection calibration. The authors also show that abstractive document compression with Qwen3.5 and Qwen3 instruct preserves retrieval quality better than keyword compression, enabling more candidates within the context window without destroying rank. 1. Accuracy. That's a wrap on today's AI paper highlights. Thanks for watching.